Alright, here we go with Unit 3.07. We're going to do some exponential and log review. A couple things to just note when going through these, make sure that you write out the questions. Okay, I can't be more clear about that. This will allow you to start reviewing on your own. So write out the question, and that brings me to your answer, which should not just be some number written down in the bottom of the page. You need to also write, and I will include the word explain, your answer. Okay, and this is important. Okay, so keep that in mind, and now let's go ahead and take a look at some of the problems. Let's take a look at number 3, and I'll clear out a little space here. So all we're doing is taking the natural log of both sides so that we can bring down our exponent, and there we go. And so we simplify this, and we'll end up with x ln of 5 on the right and x minus 1 quantity times ln of 2 on the left. So we can go ahead and divide by the natural log of 2 on both sides, and when we do that, it'll cancel there, and here we'll have natural log of 5 divided by natural log of 2 times x. And you can compute this value. Okay, I'm not going to compute it right here. We're just going to call it a for the ease of the problem. So what we've got now is we've got x minus 1 times ax. And so now I've got to solve for x, and so you got to think about it, I got to get x all by itself, right? So I've got to get it onto one side first, and you could do this in a couple of different ways, but I'm just going to go ahead and subtract x on both sides. So I'm going to have negative 1 is equivalent to ax minus x. And so now I can factor out an x here, and I'll have x times a minus 1, which is of course just some number. And that is all equivalent to negative 1, and so x will be equivalent to negative 1 divided by this number a minus 1. Alright, so let's take a look. Here's 6 problems. None of them are anything new. Go ahead and pause the video and give these a try. I'll say a few things about a couple of them, but for the most part, you should be able to handle it. Make sure, of course, to write down the questions and write down your answers and explain them, and bubble in any questions that you might have that come up along the way. Alright, I hope that went well. First off, let's just talk about number 1, the natural log of e. Remember, the natural log means that you're taking the log base e, and so here you'd be taking the log base e of e, which means you're asking the question, what exponent would I raise e to get e? And so that, of course, is 1, and it makes sense because e to the 1 is e. Number 2 is kind of up to you. Explain what it means for something to grow or decay exponentially. Well, that's not up to you, but the second part is when something grows or decays exponentially, as we've talked about, it will increase or decrease by the same proportion or percentage each time period, right? So something increases by 10% every year. Notice that it's not increasing by 10 units every year, it's increasing by 10%. So it will increase by more if you have 100 of it than it will increase if you have, say, 10 of it. You have $1 and you believe that you can double your money every week. This is a kind of interesting problem. At first it probably seems doable, right? How much will you have after 1 year? So you'd have $1 and you'd multiply it by 2 to the 52. And you'd be kind of surprised how much money that is. So do you think this is feasible? Well, probably not, because what will happen, say you get to 30 weeks through the year, maybe even a few less than that, and you're having trouble doubling that money, right? Doubling a dollar isn't too bad, but doubling thousands of dollars in a week can be tough. An isotope decays 13% every year. Another isotope has a half-life of 8 years. If you start with the same amount, which one will you have more of after 20 years? So that's just comparing the two situations when your time, or your time period, your exponent is 20 years. One note that if you're decaying at 13% every year, that means that every year you're multiplying by 87%, right? By 0.87, because you're retaining 87%. Make up your own question, that's for you. And then here, to solve for x, we got to think about how this is similar to a quadratic function, and you can go ahead and factor this. Notice here that instead of e to the 2x, we have e to the 4x. So that's going to be e to the 2x and e to the 2x plus 4 and plus 4. All right. Okay, hope that went well. Looking forward to seeing you guys soon. Have a good one.